Okay, this is Fran and Sarah, and we're doing rational functions in curve sketching. Yay, son. Woo. Okay, first thing you're going to do is find the intercepts. So to find your x-intercept, you want to know what makes f of x equals 0. And if you come over here, this is a rational function. So we'll figure this out later, but you want to know what makes f of x equals 0. So what number can you put in to make the equation equal to 0? To find the y-intercept, you put 0 in for x, and then see what you get as your answer. And we'll do an example of that later too. Okay, so your second step is you want to find the horizontal asymptote, or HA. And there are rules for finding this. There's actually 3 rules. If the degree of the top of the equation is less than the degree of the bottom, then the HA is at y equals 0. And that's on the x-axis. If the degree of the top is the same as the degree of the bottom, then you look at the leading coefficients. And I have an example of this that Fran's going to take over.
Okay, so our example, f of x is 2x squared over 3x squared plus 1. Your leading coefficients are 2 and 3, so the horizontal asymptote is, at y, is 2/3, 2 over 3.
Okay. And then, if the degree of the top is bigger than the bottom, then there's no horizontal asymptote at all, but there's a slant instead, and that's kind of rare, but we do have some problems with that later on. Fran's going to explain how to find the vertical asymptote in an example.
To find the vertical asymptote, if it occurs at x is not in domain, f of x, 2x plus 3 over 3x plus 6. If you put in -2, you end up having 0 on the bottom, and that's what you want to find. So if you substitute in -2 for x, you get -4 plus 3 over 0, and that equals -2 over 0.
So then your vertical asymptote is x equals -2, which is pretty self-explanatory, I think. And then for this rule right here, if the degree of the top is less than the degree of the bottom, then the horizontal asymptote is at y equals 0. We'll have an example of that too, and Fran's going to explain that one.
Okay, so f of x is 2x over 3x squared plus 1. The degree of the top is less than the degree on the bottom because, see, right here you just have x. And since you just have x, you're going to have a 1 there. But x squared is bigger, so y equals 0.
Okay, that is our explanation of rational functions in curve sketching, and I hope it made sense. Okay, now we are going to do some examples of rational functions in curve sketching, and Fran is going to start out with our first explanation of a problem.
Okay, so the first problem that we're going to do is from page 278, number 7. Obviously number 7, but, so the problem is f of x equals 2 over x plus 2. Okay, so our horizontal asymptote is y equals 0 because if you look at the problem, obviously it's bigger on the bottom than it is on the top because you have an x on top. Your x-intercept, you don't have one because there's no x on top, obviously. And your y-intercept is y equals 1. You put 0 in for x. Your vertical asymptote is x equals -2 because -2 plus 2 equals 0, and that's what you're trying to get is 0. And we don't have a slant. So when we go to our graph, your horizontal asymptote is along 0, which you can obviously see, and your vertical asymptote, like I already said, is -2. So see, you have to draw your little line there. Okay, and to get this curve, hence curve sketching, you have to go through the points 0 and 1. So to get that, it's curved because you can't go through your vertical or horizontal asymptote. So that's why it's curved like that. And this line here, to figure out where your curve is, you have to pick a point past -2 and put it into your equation up there. So we put in -3. So if it's negative, then it's going to be on the bottom like this. And if it's positive, then it's going to be on the top part of the graph. That is problem number 7. Okay, so the second example problem we're going to do is from page 280, it's number 44. And our problem is f of x equals x over x squared minus 9. Okay, so our x-intercept is 0 because how does f of x equal 0? And of course just put 0 in there. Your horizontal asymptote is 0 because obviously, again, the degree on the bottom is bigger than the degree on the top, so you have squared, and that would be a 1 right there. Your vertical asymptote is 3 and negative 3 because how do you get 0 on the bottom? If you put in 3 squared minus 9, that's 0, and if you put negative 3 squared minus 9, it's going to be 0 too. And our y-intercept is 0 because you have to put 0 in for x.
Okay, and now the graph for this, your horizontal's at 0, so you do it along.
Hey, sexy.
Okay, JM just started our video. All right.
Yeah.
Let us close the door.
Okay.
Okay.
Okay, good. Okay.
All right, it's recording actually.
Okay, so this is my friend Sarah again,
hi.
and she's going to be explaining this, our third example problem, and it's one that we did in class. Okay, so Sarah, take it away.
Okay, so the equation is f of x equals x squared minus x over x plus 1. And so your x-intercept is how does f of x equal 0? So if you put in 0 and 1, you're going to get this whole equation to equal 0. So that makes sense that those are your x-intercepts. Your y-intercepts is you put 0 in for x. So when you put 0 in for x in this equation, you come out with 0. Okay, there's actually no horizontal asymptote. There's a slant. Because the degree on the top over here is bigger than the degree on the bottom.
Check that out.
Yeah. Okay, so you do have a vertical asymptote, and it's...
Okay, so the fourth example that we're going to do is from page 280, and it's number 41, and Sarah's going to explain this.
Okay. So the problem is f of x equals x squared over x squared plus 9. So to find your x-intercept, it's how does f of x equal 0? So obviously, if you put in 0, then it's gonna equal 0. So your x-intercept is 0. Y-intercept is you put 0 in for x. When you do that, you get the answer to be 0. So your x-intercept is 0. And then your horizontal asymptote.
Okay, so we're about to do our last problem, but we really like Sarah's shoes. Yay!
Yes.
Okay, so our last example is number 74, excuse me, from page 281, and Sarah's going to explain this one.
Okay, this one is g of x. Ooh, got a little switch up there. Equals x cubed over 2x squared minus 8. Alright, so your x-intercept to start off is how does f of x equal 0? If you put 0 in, that's how it's going to equal 0. And there's pretty much no other possibilities. Y-intercept is put 0 in for x, and when you do that, you get 0 once again. And there is a slant, actually, but we'll come back to that. The vertical asymptote is at x equals 2 and x equals negative 2. Because if you put 2 in for x here, you're going to get 0 on the bottom. If you put negative 2 in for x, you're going to get 0 on the bottom. Okay, so since there's a slant, there's no horizontal asymptote. So what we're going to do is what we did in a previous problem, where we divide the bottom of this equation into the top of the equation. So we come over here and do 2x squared, and we need to fill this equation in since it was just 2x squared minus 8. We're going to need to do 2x squared plus 0x minus 8. And then over here we're going to divide it into x cubed plus 0x